There are generally two types of Hess law that we need to talk about. The first one is using delta HF values. So for delta HF, I can draw this Hess cycle. I've got reactants going to products. I want to find delta HR standard for that. I don't know what that is. However, I do know, because I can look these up in the book, the delta HF values. Remember, delta HF formation, taking the elements and making things. So, delta HF are the values are going to tell me elements going to reactants and elements going to products. So my cycle looks like that. Elements down the bottom, arrows point up, like so. You're happy that why they point up? Because formation data is elements giving me compounds. So they've got to point up like so. Okay, so you'll notice it's a slightly more complicated, because my arrows aren't going the same way. So these are going to be delta HF values for reactants. These are going to be delta HF values for products. We've got to form an equation that I can work that out for. Right. There's different ways you can do this. I do it that I think of, if you draw a little circle in the middle and put little clock arrows on it, like clockwise arrows. Sometimes this freaks people out. If it freaks you out, I can tell you no way I did it. Can you see that this arrow and that arrow follows my clock direction? Yeah? This arrow goes the opposite way to this arrow. Yeah? So, the way to do it is delta HF for reactants plus delta HR, which is what I want to find, is equal to the arrow that goes the opposite way. Okay, so if you draw a little circle, always two arrows, it's kind of got to be, two arrows will be going in the same direction, one arrow will be going the opposite. The two arrows that go the same will equal the arrow going the opposite way. And if you do that, you'll always form the correct equation, even if they give you a crazy Hess cycle that you've never met before. So, if you want to rearrange that, delta HR is going to equal delta HF for the products minus delta HF for the reactants, like so. So all I've done is taken this and moved it to the other side of the equation. So if you're happy with maths, you're happy with, just move it to the other side.
Why are there like R's and F's?
Right, the R is for a reaction, any old reaction will do. F is specific for formation data. Delta HF, enthalpy of formation. Delta HR, enthalpy of reaction. Enthalpy of reaction is the enthalpy for any old reaction for the equation given.
So I don't see why you use F for one and R for the other. Formation.
Because for these are formation, they were the equations we were doing earlier. Like always taking, formation is always elements go into a compound.
Oh, okay.
Yeah, so we're doing an example next time. So this is a typical Hess cycle example. They've given me the key thing, look at the data that they've given you. They've given you delta HF data. Don't worry about what they're asking you to find, look at the data they've given you. Delta HF. So, before we do anything, if they give me delta HF data, what am I going to put here? I'm going to put the elements here. So, what elements do I have to deal with? Nitrogen. How would I write nitrogen as an element? N2, and it's in the gaseous state. And I've also got oxygen, O2, in the gaseous state. Now the number of atoms should balance. So I have I've got 2 nitrogens there, 2 nitrogens there, 2 nitrogens there. How many oxygens do I have here? 2 there, 4. How many there?
4.
So I need a 2 there. So at each apex, you've got the same number of atoms. Let's write delta HF for nitrogen monoxide, the equation. I start with my elements in their standard states. I can only form 1 mole of NO, so in order for that, that's a half N2 plus a half O2 to give me NO. That's what that equation refers to. For this one, it's going to be a half N2 gas plus O2 gas to give me NO2 gas. That's what that number is referring to. Yeah, with me so far. So those are the equations we were doing yesterday. Yeah, happy with that? Always forming 1 mole. Okay. Right. How do my arrows go? How are my arrows going to go? They give me formation data. My arrows are going to go up. Like so. I'm going to put my numbers on now. What am I forming here? I'm forming NO. What number do I need to put on this arrow here then? NO is equal to 90, but that 90 refers to only making 1 NO. How many NOs do I make? 2. So I need to use 2 times 90, which is equal to 180 kilojoules per mole. Do I need to worry about oxygen at all? No, because it's an element, so it's going to be 0. How about NO2? 33 relates to forming 1 NO2. I make 2. So 2 times 33 is equal to 66 kilojoules per mole. Okay, let's draw my circle on, just so I make sure that I form my equation correctly. If I do that, 180 plus delta HR is equal to 66. So if I rearrange that, delta HR equals 66 minus 180, which means delta HR is going to equal minus 114 kilojoules per mole. So example number 2. This is what I want to find. Delta HR. They've given me delta HF data. So, what do I need to put down here? I need to put my elements. So, go through elements, I'm going to end up with a zinc, which is going to be solid. Carbon is going to be solid. How about oxygen? Gas is going to be O2 gas, and how many do I need? A I've got 3 there, so I need 3 over 2 there. So just make sure everything balances. Okay, now, arrows go up, like so.
I just got some.
And now we're going to put our numbers on. So I've got delta HF for zinc carbonate is minus 812 kilojoules per mole. Job done. Other side, I've got zinc oxide is minus 348, and I've also got carbon dioxide is minus 393. So let's put those together. So it's going to be minus 741 kilojoules per mole. You do your circle. Following around my circle, I know minus 812 plus delta HR is equal to minus 741. And therefore, delta HR is equal to minus 741 plus 812, which equals 71 kilojoules per mole. So that's an endothermic reaction, okay? Which hopefully won't surprise you when you think back to group 2 chemistry and you know that this is, what type of reaction is this? This is a, not redox, I'm heating something and it's breaking down into 3 thermal decomposition.